So either way goes. Just remember the logic. You need to understand the logic, not to memorize the logic. Understand it, make you feel easier, okay? More comfortable. Don't bother yourself too much to memorize this kind of things. You need to understand how to analyze the problem rather than memorize them. It's so hard to memorize all of this. I hate that. Okay? So if you understand the logic behind the problem, you can easily solve the solutions. So this is the results. The second way is actually the expenditure function. So E is the smallest expenditure that allows the consumer to achieve a given level of utility, which is 2,500. All right? So differentiating with respect to the price of the first good yields the compensated main function for the first good. This is the outcome in some previous slide. Okay? And a $1 increase in P1 on each of the Q1 units purchased requires the consumer increases spending by Q1 to keep utility constant. Yeah.
Excuse me, Professor. The U-bar mean the original utility?
Yes. Something we require, just like that one. And let's go back somewhere. Oh, in previous chapter. It must be in previous chapter. Wait a minute. I'll show you where it is. 1 minute. Should be in chapter 3. The last slide. The last slide in chapter 3. So the objective function is the expenditure. We want to minimize our expenditure and given the utility function to be some specified level, some required level. So you may see if we have the expenditure function, then we may find what? We may find the Hickson demand function. Okay? So the same way, let me give you how to do this. So do you have any problem with these two solutions or these two ways to solve the problem? Now, let me give you this example. Minimize P1 Q1 plus P2 Q2. This time, we don't need to specify the price. We just give it a general symbol to represent the price, subject to, say, Q1, Q2. Okay, make it simpler. This is the Cobb-Douglas utility function to the power of 1, 1, and make the requirements of the utility to be U bar. All right. So Lagrange again, P1 Q1 plus P2 Q2 plus lambda U bar minus Q1 Q2, and Lagrange lambda equals U bar minus Q1 Q2. Lagrange 1 equals P1 minus lambda Q2. Lagrange 2 equals P2 minus lambda Q1. Right? So Q2 is actually P1 Q1 by P2. Can you do this from these two equations? Yes? No? Yes? No? Hello? Yes or no? Can you do this? Yes, right? Now, U bar equals Q1, Q2, and Q2 is P1, P2, Q1, right? So, we have Q1 to be the square root of what? Of U bar P2 P1. Is that right? Yes? Yes or no? Oh, yeah. Okay? Shh, 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 shh. All right? Okay, so now let's call that Q prime, or the Hickson. The Hickson demand function looks like this. And do you remember, in this case, this kind of utility function, the Marshallian demand would be, since it's 1, 1, right? It would be y half. 1/2 of y divided by P1 only. All right? So this is the Marshallian demand curve. This is the Hickson demand. What's the difference? All right, let's have a look at this. Which one do you think? The steeper demand curve or the flatter one corresponds to Marshall, and which one corresponds to Hickson? So when the price rises from this level to this level, too excited. From here to here, you will see the steeper one. The steeper one is the Hickson, right? And the flatter one is the Marshallian. Okay? So Marshallian, when the price goes up and your quantity demanded decrease from this level to this level, and what would be the decisive factor, the deciding factors? P1 and Y. Okay? You need to know how much money you have in your pocket. Okay? So from here to here, your utility level would be different. Actually, you will feel worse off because the price goes up. Okay? However, from this point to this point, the Hickson function, your demand curve looks like this, Q1 Hickson. And you don't need an Y because it's compensated. So we don't care about how much money you have in your pocket. We care about what's the level of utility you are on. Okay? We care about the level of happiness, so we care about the level where you are at. That's the difference, okay? So now you learn some techniques to solve Marshallian demand curve or Hickson demand curve. Just remember the basic idea, the basic logic is that compensated. Why we call it compensated? We want you to be compensated so that you may stay on the same indifference curve with the same level of happiness, with the same level of utility. Okay? So all you need to do is to understand why we use compensated, the term compensated. Without compensation and with a increase of price, you will be worse off. Okay, so we compensated you so that you may stay or remain on the same level of happiness. That is what we call compensated. Is that clear? So all you need to know is that the demand function, the demand curve, we learn since our junior high school time is actually something uncompensated. Something uncompensated. That is Marshallian. And actually in this world, in the real world, the only thing we may observe is Marshallian demand curve rather than Hickson. Hickson is something we use to analyze. We use to analyze how we feel, how the consumer welfare or basically consumer welfare or consumer surplus. Okay, later on I'll introduce this part. Why? Okay. Next hour I'll talk about this. Just a little bit. Don't worry too much. Okay, take a break. Don't want you